In this video, we're going to quickly go over how to use nPlot to plot your data from your lab, how to fit a model using nPlot to your data, and then how to use that model to linearize your data to get a straight line fit that you can then use to kind of verify your model. So we're going to start just by pasting your data. Now, if you copy your data into something like Google Sheets, it's easiest just to highlight your data and just copy and paste it in here, which is what I'll do. Notice in the beginning, nPlot does not do anything when you paste in your data because it's waiting for you to label it. It forces you to label your graph like a good student. So in my case, we have time on the x-axis in seconds, and we have position on the y-axis in centimeters, and we'll label our graph position versus time. Now we have a nice graph here from nPlot, so we want to use it to fit a model to it. If you notice, there is a number of models that are pre-programmed into nPlot. These are the kind of common ones you would see in a physics class. So we're just going to, when you have brand new data, you're unsure at all what type of relationship it is, you can sometimes try to look at it. We went over different types of models. We can see this one kind of curves up a little bit. So you can, if you're unsure, if you forget what each shape goes with each model, you can always just click on them. And so I always say start off simple and get more and more complex until you get a model that fits your data fairly nicely. So relation, that doesn't fit. Proportional, not really too good. Proportional, getting a little bit closer to our data, but not great. Linear, getting even closer, but still not too great. And a square law fits our data very, very well. And again, it's okay if your data, again, this is data we're taking from labs in school. So it's okay if your data bounces around. It doesn't have to be perfectly on the line, but this is pretty close to being on that line. So there's a good idea, or I'm pretty confident that this data fits this relationship pretty well. And now if we look at it in this case, it's a square law. So it says that our y variable, which is position, is equal to some constant times our x variable, which is time squared. And it gave us that constant as 33.87, or about 34. This is saying that position equals something like 34 times time squared. So right now, your graph is nicely drawn. You can right click on it and either save it as an image to use later somewhere, or what I would do if you have a Google Doc or something open, you can just copy the image and paste it into your Google Doc to use later on. Now be careful here. You can save things in nPlot. If you close the window, all your data is going to be gone. But you can save it as like a weird web file that you can open up again. But I think it saves it in your browser memory, so it's not super great, but it's so quick to do. I would just copy the image and paste it when you're done, and that's as simple as that. All right, so now we have a graph. We're pretty confident in our relationship. We have a model. We have the nPlot gives us the constants that go into our model, but we want to go back and we want to actually try to linearize our graph. What that means is I want to look at using the model that I think fits the best. I want to modify one of my variables so that when I regraph it, I get a straight line as opposed to a curve. And what I'm going to do here is I'm going to look at my model, and I'm going to look at this one here. The variable is not by itself. So my x variable, which is time, and my model is time squared. So I'm going to kind of make a fake variable that is not just time, but is time squared. So I'm going to go back over here. I'm going to take all of my time data, and I'm going to square it all. Now you could do this in a Google Sheet or by hand and just retype it back in. So I'm going to square it and re-put it on this graph. And if you notice, so I'm going to turn off this fit because it's going to change the data now. Because I'm going to change this. Again, you make sure you save your original graph first before you go back and change this. I'm going to paste in my new data. And if you notice, it doesn't look curved anymore. It looks fairly straight. So I'm going to change my labels. So time I change to time squared. So I'm going to do caret T, or caret 2 rather. And that's how it does superscripts in here. So if you notice, my label down here changed to time squared. Got to be careful. My units are also going to be squared now because I changed my variable. I squared my variable, so my units also get squared. My position variable stayed the same, but this is now a graph of position versus time squared. So I'll make sure I save that. And now I can try to fit a new curve. And again, I'm trying to linearize this. So the idea is that if I make up a new variable called time squared, and this relationship here is true, that if I plot position versus time squared, I should get a straight line. And in this case, should have the same slope as my other graph. and it just verifies that my other fit was correct. So I'm going to try linear fit. Look at that, it fits pretty well. Again, it's okay if your data points bounce around a little bit. They're still pretty close to the line, and usually you want to see some kind of like a little bit above, some a little bit below. Kind of that's just the randomness of the lab. And if you notice, our constant here is about 33.4, which is very close to what it was before. So I would right click on this, copy the image, paste that into my lab too, because you'd want to turn in the original graph and the linearized graph. But there you go. It's how to use nPlot to graph data to fit a model to it, and then how to linearize your data as well.